In this video, we're going to go ahead and talk about radicals. So this is just going to be a brief overview and a brief description on how to simplify radicals. We're not going to go into any extra detail of multiplying or dividing, anything like that. It's just to refresh you a little bit about what is a radical and how do I simplify it. So radicals look like a check mark / division bar type of deal. And basically, we call this the radical symbol. And what's underneath it we call the radicand. So I like to do the joke because we can. If you like Moulin Rouge, you may like that. But whatever's underneath, whether it's a number, expression, whatever it is, that will be called the radicand. And then you may or may not have a number above the check mark. Now, most of the time we'll just have the symbol that looks like this. This is actually the square root symbol. And there's actually an implied 2 above that root symbol, radical symbol. And we just don't put it there because it's always your assumed default because you can't go anything lower than a square root. Okay. But you may have a 3 there for cubed root, fourth for fourth root, go on, so on and so forth, right? Now, radicals are great because they help us to undo exponents. So to undo a square, you would do the square root. To undo a cube, you would do the cubed root, and so on and so forth. So that's really why we study radicals and square roots and such. So let's see. Let's go on to our next example. So how do we simplify a square root? Well, what you want to do is you want to break out all of the perfect squares, any factors that are perfect squares, and you also want to pull out as many of the possible pairs of the variables. So what I've done for you guys is, it's actually being cut off right now, but there we go, is at the top there are the perfect squares. And these are a great thing to have memorized. They will come back to haunt you later on, I promise, okay? So what we see is we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. These are just some of the perfect squares. You can keep going from there. These are great things to have memorized. We're only going to do square roots. We're not going to get into like cube roots or anything. So for the time being, just memorize the square roots. So let's look at how to simplify the square root of 8x to the 5th, z to the 8th. Now, start with your number, 8. Is 8 a perfect square? Alas, it is not. Okay? 64 is, right? But 8 is not. So what we want to do is we want to simplify the square root of 8 first by looking for perfect squares that divide it. So as we look through these, what are some perfect squares that would divide it? What's the largest perfect square? Well, it looks like the largest perfect square would be 4. So to break it down would be 4 and 2. And then we want to go ahead and just simplify that. So to simplify square root of 8, we would take, it breaks down into square root of 4 and square root of 2. Well, we can simplify square root of 4 to be 2. Okay, so it's just an operation, right? As soon as you take the square root, it goes away. And then you have square root of 2 just chilling inside. So square root of 8 just simplifies down to 2 square root of 2. So far as we've broken it down, we have a 2 on the outside, and we have a 2 on the inside. 2 is not a perfect square. It's not divisible by any of these perfect squares besides 1, but that doesn't count. So that's all we can do for right now. Now let's look at x to the 5th. So x to the 5th is really 1, 2, 3, 4, 5. 5 x's underneath the square root. Well, to see how many x's we can pull out, we have to look for pairs. Think of like pairs of socks here. How many pairs can I pull out? Well, I can pull out 1, 2, and then we have that one scraggly sock that we lost the other sock to. No idea where it went. So that has to be left inside. So we can pull out 2 x's and then leave 1x inside. Another way to do this is x to the 5th, divide it by 2, since you're taking the square root. So 5 divided by 2 is 2.5. So that means you can pull out 2, but there's still 1 that's left inside. Didn't quite make it out. Okay, so you see we have x squared on the outside and x on the inside. Now let's do z to the 8th. So there's 8 z's underneath the square root. How many pairs can we pull out? Well, we can actually pull out 4 and have no leftovers. And that's because it's an even number, okay? 8 divided by 2 is 4. And there's not going to be any leftovers underneath. So that would be how you would simplify a square root. So keep practicing that, and remember, study those square roots because they're going to be vitally important as we go along, especially when you get to quadratics. Woo woo! Okay, good luck!